Hey guys, Professor Calculus is here, and today we got a really interesting integral here to solve. But before that, make sure to like and subscribe. And um, as it is free, and you can change your mind always later. So to solve this integral, I personally found another solutions, but my preferred technique is always Feynman's straight-off integration. Thus, I'm going to define I of t to be the integral from 0 to 1 of, negative ln x to the power of t dt dx. And if I find I of half, that means that I have found the integral from 0 to 1 of negative ln x to the half dx, which means it is the integral from 0 to 1 of root negative ln x dx. Now, if I take the derivative of I of t, I'm going to be taking the total derivative of the integral from 0 to 1 of negative ln to the x to the t dx. And I prime of t would be the integral from 0 to 1 of, this is going to become partial derivative, it's partial t of negative ln x to the power of t dx. And my integral finally is going to be the integral from 0 to 1 negative ln x to the power of t ln of negative ln x dx. So from here now, I'm gonna use a variable substitution. I'm gonna let u be equal to negative ln x, and therefore negative u is ln x, and thus e to the negative u is equal to x. dx is negative e to the negative u. And my bounds, when x equals to 1, u equals to 0, and when x equals 0, u equals to infinity. So my I prime of t is going to be the integral from infinity to 0. U, we gotta replace u here. So u to the t, ln of negative ln x is ln of u, and for dx, e to the negative u, negative e to the negative u du. And this negative is going to get multiplied in this integral, and it's going to give me I prime of t to be equal to the integral from 0 to infinity of u to the t ln u e to the u du, e to the negative u du, as the negative sign changes the bounds of the integral. Now here, we're going to use gamma function. Gamma function is defined as gamma of x equals to gamma of s equals to the integral from 0 to infinity of u s minus 1 e to the negative u du. Notice that how similar this integral is to this integral right here. And if I take the derivative with respect to x of gamma function, I'm going to get the integral from 0 to infinity u to the s minus 1 e to the negative u. The derivative of this is ln of u du. So if I replace it with, if I say gamma of t plus 1, it's going to be the integral from 0 to infinity of u to the t plus 1 minus 1, which is going to go away, e to the negative u ln of u du. And thus, gamma function, gamma prime of t plus 1, is going to be I prime of t, since this function here is I prime of t. And if I now integrate both sides with respect to t, gamma prime of t plus 1 dt equals to I prime of t dt. This is going to become I of t equals gamma of t plus 1 plus c. Now, my integral originally was negative, the integral, the I of t was the integral of 0 to 1 of negative ln x to the t dx equals to the integral of gamma of t plus 1 plus c, some constant of integration, and we gotta find this constant of integration first and then the rest of the work that we have to do. So for this, I'm gonna let t be equal to 0 and see what happens. If t equals to 0, as t gets equal to 0, it's gonna be negative ln x to the 0 dx equals to gamma of 0 plus 1, which is 1, plus c. So any number to the power of 0 is 1, thus dx equals gamma of 1 plus c. And this integral is going to value 1, which is gamma of 1 plus c. Gamma of 1 is 1, and 1 equals 1 plus c, thus c should be equal to 0. So the integral, the I of t, which is the integral from 0 to 1 of negative ln x to the t dx, is gamma of t plus 1, and we were looking for I of half, which is going to be the integral from 0 to 1 of negative ln x to the half dx equals gamma of half plus 1, which is gamma of 3 over 2, and therefore this integral from 0 to 1 of root negative ln x dx is gamma of 3 over 2, and gamma of 3 over 2 is root pi over 2. Thus, I'm going to get the result of root negative ln x, the integral from 0 to 1 is root pi over 2, and that is the final answer of the integral here. Thank you for watching this video. Please like and subscribe, and I'll see you next video.